Good morning, Dolphy Gilpin, here at the Radisson JFK Airport. The time is now 2:09. That's in the morning, early morning, wee hours of the morning here. I'm on the 11th floor of the Radisson, and I'm on the amazing 5x12 matrix and its application. And we are moving into circuit analysis. Now we have set up a 3x3 matrix, and in previous session, we have calculated the determinant delta of the circuit, and we want to find current I1, I2, and I3. But first we have to also find delta, which is the determinant of the source matrix. All right, let's just quickly drop in some very small values for these resistance here. To make our competition very easy. All right, we are using a real voltage input, 480 volts, which is usually defined like the power in a horizontal escalator, something like that, or elevator, 480, 960 volts. And we say now that delta was equal now to the determinant of the source matrix, and we quickly want to find it here once more. Delta R11, we say now that it refers for mesh 1. R1 will be 0,1, and that will be 0,5 resistance. 5, we write as 0,5 just to maintain the duality in the numbers in the PDM processing. We just want to show the similarity here. 0,5. Now R12 would be the resistance common to mesh 1 and mesh 2, which is 0,4. And R13, resistance common to 1 and 3, which would be 0, 0 in this case. Now R21, resistance common to mesh 2 and mesh 1 would be 0,4, and a mutual resistance is taken on a negative sign. Now R22 would be 3 and 2, 5 and 4, 9, 0,9 voltage, rather resistance, and R23 would be resistance common to the second matrix and the second mesh and the third mesh, which is 0,3. And that takes on a negative sign. The mutuals won't take on a negative sign. Now R31, resistance common to third and 1 will be 0, 0. R32, resistance common to 2 and 3, or 3 and 2, which will be this is the second mesh third, this would be 0,3, and R33 would be 5 and 2, 7 and 3, 10. And so we find the determinant of this now, and that would give us delta. Now we say now to find the current I1. I1 is equal to N I11 over delta. And for the numerator value, we put in now the voltage value. I would say now the voltage now V1 was equal to 480 volts. V2 was equal to 0 for mesh 2, and V3 was equal to 0 volts for mesh 3. And for V equals IR now, V equals IR, or rather RI, same thing. We know that 480 volts, 0, 0, was equal now to 0,5, 0,4, 0,0 minus 0,4, 0,9, 0,3, 0,0, 0,3, 10, and I1, I2, and I3. And therefore now I1 is equal to Ni I11 over delta. And I2 was equal now to N I2 over delta. And I3 is equal to n I3 over delta. So delta is common, and this is a numerator value. Let's calculate the numerator value by putting it in now the voltage in the first column. So for NI1, that's equal now to 480, 00. Sorry, we shouldn't have this. 480 is also this. And I1 is equal now, which is a numerator value, is equal now to 480, 00, 04, 09, 03, 00, minus 03, and 10. That is the determinant of that. Likewise, NI2 is equal to NI2 over delta then is equal now to, we replace the voltage value in the second column, and so we have 05 minus 04, 00, 04, 09, 03, and we place it in the second column, so therefore this would have been, what did it for the third column here? So let's do it in order not to make a mess here. So NI3 will be, over delta will be that, and we place this in the third column, 480, 0, and 0. And over delta, the determinant of the source matrix would be 05, 04, 00, 04, 09, 03, 00, 03, 10. And let's go back to I2 now. And I2 is equal to determinant now of 05, 04, 00. Replace it now 480, 00, and now 00 minus 03 over 10. And if we want to put it over delta now to find the current, we say that I2 now would be equal to determinant value over delta, which will be now 05, 04, 00, 480, 0 and 0, and 10 minus 03 and 10. Or is it 00, 480, 00? This is not 10, but rather 00 here. Over delta, and we know delta is the determinant of this matrix. Now, in order to find the determinant of the NI1, we simply have to take just the determinant of one column. All right? So let's do the determinant of one column to find NI1. So let's take, say, for I1. NI1 is equal now to, NI1 is up here. That will be equal now to 480 into 0903 minus 0310. That's equal now to 480 times now 10 and 9, 90, minus 9, that will be plus 9. That's for just for this element. Now the rest of the element here will be 0, 0. So the determinants for these will come out to 0. So it's just remain this. So this will be equal now to 480, multiplied by 99. Let's see if we get the sign right. 3 and 3 is 9, negative. We subtract the negative again. We get negative, negative, positive. So it's 90 plus 9, 99, 480. And this is now positive there. So we get 90, 99. So that would give us now Ni1. And Ni1 over delta would be now 480 times 99 over delta. Delta is the determinant of this matrix. And we have in previous session show you that by the algebraic method. That's not our problem here to find determinants. We just set up the model circuit and to solve them via matrix. We'll come back with some more 3x3s, and I want to even introduce to you some complex one with inductance. So let's take a short break.